David and Lucile Packard Foundation headquarters is a two-story sustainable leading office building which achieved the LEED Platinum and Net Zero Energy certification. As a head start, we're able to observe from the diagram above that California gradually reduced the amount of carbon emission by 6% for the duration of 14 years. This improvement can be related with the graph where California started to lead all the states of America by implementing most of the renewable energy in the buildings. Based on our analysis, the Packard Foundation wants to be a leading example to solve the issue of average global temperature keep rising due to vast amount of greenhouse gas emission by maintaining the global temperature not exceeding 2 degrees Celsius. Thus, the Packard Foundation building trying to reduce net annual gas and electricity use in the effort of reducing wide range of carbon emission and lowering environmental footprint. The building is oriented 40 degrees off true north in order to respond to California climate. Multi-layering shading strategies make access to winter sun and avoid summer sun, at the same time allowing fresh air into interior spaces through an operable facade. Windows make up almost 50% of exterior wall area, which supports good daylighting of the larger perimeter spaces. The specification of glass able to help in eliminate thermal bridging and would result in cost savings. The photovoltaic panels covers about 60% of total roof space, which able to supply 480 MWh in the first stimulation of the solar panels. The building facade consists of 3 different materials which provide a high R value. The highlighted material, red cedar wood paneling, able to keep the buildings cool in the summer, and it has a high thermal value than bricks and concrete. Besides, copper cladding also used as the material for the facade as 40% less thermal expansion than zinc and lead, help to prevent deterioration and failure, ensuring that it will not creep or stretch due to high melting point. Wooden studs wall is the main material of overall facade. It consists of mineral wool insulation which help in avoiding thermal bridge effect of intermittent structural elements. The roof implements the similar insulating approach, using a 2 inches thick layer of rigid mineral wool insulation over the structure and under the metal roof. Finally, for added insulating value, the concrete slab is placed on top of water impervious insulation board to provide a high insulating value of R23 in the floor. Trees are deciduous for building climate by providing cooling shade in the summer and enhancing daylighting and ventilation throughout the building. Living roof act as a microclimate which provide a heat sink to keep the building in cool condition.
During heating, the high-efficiency air source pump gathers heat and distributes hot water to large thermal storage tanks. 40.6 degrees Celsius water is piped and distributed to active chilled beam. Induced cold air that enters the chilled beam gets heated by the hot beam by convection, and then hot air is jetted out to the office surrounding. Radiant panels used to heat large flat plates in the ceiling or walls. With this, convection between air-chilled beams, radiant panels, and the building air hits the building to a stable temperature. During cooling season, a 2-cell 480-ton cooling tower is used at night to create 50,000 gallons of chilled water via evaporative cooling. This water is sent to chilled water storage tank to be stored at 14.4 degrees Celsius. Chilled water is sent to air-chilled beams by moving through a variable of speed pumps and pipes angled at 130 degrees. Induced hot air that enters the chilled beam gets cooled by the chilled beam by convection, and then cold air is jetted out to the office surrounding. With this, convection between air-chilled beams, radiant panels, and the building air cools the building to a stable temperature. The Packard ventilation system provides 100% outside air locally to the air distribution system of active chilled beams placed in the ceilings. The smaller fans used in the local air handler units inject the air near the chilled beam component, inducing room air to flow through the chilled beam and mix with the ventilation air. The HVAC system of Packard Foundation proves to be very efficient, on the order of 90% efficiency. SCADA, Supervisory Control and Data Acquisition, is a comprehensive system developed by Packard Foundation for building management staff to have complete access to environmental variables and equipment settings in the building. The 9 subsystems as above is under unified control by the SCADA system. 15,000 monitoring and control points are part of the building automation system and are connected to the SCADA system. From a single workstation, one should be able to see the current state of every building subsystem, take appropriate actions, and see the effects. For daylighting, the automated system throughout the building measures free, natural daylighting levels and automatically dim or brighten artificial light as needed. For HVAC, heating and cooling is digitally controlled with warning systems that indicate if natural exterior airflow should be utilized rather than HVAC systems. Not only does this smart system alert building managers at the main environment dashboard, but individual workers are notified right on their computer desktops. The system also will notify occupants if inclement weather is forecasted. When daytime temperatures rise above comfortable levels, a compressorless chilled beam air conditioning system takes over. When possible, occupants reduce energy consumption by operating in natural ventilation mode with windows and doors open instead of depending on the HVAC. The building management system has a dashboard that informs users when to open and close windows and sliding doors in order to optimize natural ventilation and reduce energy consumption. Both of the graph compared to the expected heat energy use and the first data collected for the energy used. Based on the graph above, we are able to observe that the measured monthly energy use in January, November, and December didn't meet the target of the modeled monthly energy use, as much more heat is required during winter season. In contrast, less cooling is needed during summer season as the coated glazing elements are able to block most of the daylight radiation from penetrating towards the interior. Packard Foundation headquarters received high satisfactory feedback for the above categories, especially in thermal comfort and the aspect of air quality. Here's an interview about the post-occupancy evaluation. Hi, my friend. Since the Packard Foundation sustainability design sounds really effective, what's the evaluation and feedback of post-occupancy?
Oh yes, Packard Foundation received a very strong general approval from staff where 97% say that they were satisfied or very satisfied with the building in general.
Oh wow, congrats for the successful control system. By any chance, is there any negative feedback from the occupants?
Well, soon after occupancy, the air source heat pump failed, creating a cold building in the morning and immediately raising questions among the building occupants about the relation of failure to Z&E design.
Since the building is completed and occupied in mid-2012, the building has experienced its first full year of operation. It has successfully demonstrated that the planning and design objectives have been well met. The Packard Foundation managed to achieve the target of 35% carbon reduction in 2013 as an accomplishment of a demanding task and plans to reach 80% of carbon reduction in 2050.